Welcome everyone. Today we're continuing 7.5, solving special types of linear systems. So the first thing says, we're going to talk about a little bit of vocabulary. When the equations of a linear system are written in slope-intercept form, you can identify the number of solutions of the system by looking at the slopes and the y-intercepts of the lines. So slope-intercept form, remember, is y equals mx plus b. One solution is when they have different slopes, because that means that they will cross each other. No solution is when they have the same slope and different y-intercepts. So no solution would be when they are parallel. And infinitely many solutions when they have the same slope and the same y-intercept. So that's when they are just one solid line. Now, if we take a look at this one, it says, tell whether the linear system has no solution or infinitely many solutions, and explain why. Well, we need to get these two into slope-intercept form. So, we could just start with 5x plus 3, y equals 6. We subtract the 5x. 3y equals negative 5x plus 6. Divide by 3. Y equals negative 5 over 3x plus 2. So this was equation 1. Equation 2, negative 5x minus 3y equals 3. Add the 5x this time. So we get negative 3y equals 5x plus 3. We divide by negative 3. Y equals 5x over 3 negative minus 1. So these have the same slope but different y-intercepts. So that means that this is no solution because they have the same slope but different y-intercepts. Here we know that y equals 2x minus 4. This one we can add 6x. To get 3y equals 6x minus 12. If we divide by 3, y equals 2x minus 4. And that is the same equation as the top one, y equals 2x minus 4. So that means there is infinitely many solutions because they have the same m and b. They have the same line. This next problem says an artist wants to sell prints of her paintings. She orders a set of prints for each of 2 of her paintings. Each set contains regular prints and glossy prints, as shown in the table. Find the cost of one glossy print. Well, we need to write and solve a system of equations here. So our first one we know is 45 And that's our 45 regular, so 45R could be, plus our 30 glossy, or 30G, equals $465. The second print that she gets is 15 regular, so 15R, plus 10 glossy equals $155. So if we solve this, we can solve this by using any of our forms of solving systems: graphing, substitution, or elimination. It looks like this one's going to be easiest to solve using elimination. So what I'm going to do is that I know that 15 times 3 would equal 45. So I'm going to multiply this all by 3. So 45, or 3 times 15 gives us 45R. 3 times 10, 45R. 3 times 10G gets us 30G. And 3 times 155, that equals 465. Now if I take this equation, bring it down, 45R plus 30G equals 465. Well, to eliminate these, I'm going to subtract. Now 45R minus 45R, that cancels, that eliminates. 30G minus 30G, that also cancels. 465 minus 465, that also cancels. So what we have is 0, 0. Now that means that we have no solution, and that this problem didn't give us enough information. So there was not enough information to find the price of one glossy print for this problem. Here it says, without solving the linear system, tell whether the linear system has one solution, no solution, or infinitely many solutions. Here we have 6x plus 2y equals 3, 6x plus 2y equals -5. I can just take these. I see that there's two of the same numbers, so I can just subtract these two. 6x minus 6x, that eliminates. 2y minus 2y, that eliminates. And 3 minus a -5, that equals 8. So we have 0 equals 8. Well, we know that doesn't work. 0 is not the same as 8. This one has no solution. Here we have x minus 3y equals -15. 2x minus 3y equals -18. I can solve this one using elimination. I'm going to multiply this by 2. So we get 2x times -6y, and 2 times -15 is -30. So now I can subtract these, which eliminates my x. -3y minus 6y gives me a -9y, and -18 minus -30 gives me -48. Well, I know that I just have a y now, so I could solve this to figure out what y and figure out what x is. So I know that this one is only going to have one solution. This one will have an x and a y. Okay, our next one, 5x plus y equals -2. -10x minus 2y equals 4. I'm going to try to eliminate, and I'm going to multiply the top equation by 2. So 2 times 5x gives me a 10x, positive 10x. 2 times y gives me a positive 2y, and 2 times negative 2 is negative 4. So, negative 10x plus 10x is going to give me 0. Negative 2y plus 2y is giving me 0. So this side of my equation is 0. 4 plus a negative 4, that's 0. 0 does equal 0. So I know this has infinitely many solutions. Okay, we're solving this one using substitution or elimination. Here I see that x and negative x can be eliminated, so I can cross those out. We're adding these together. Negative 2y and 2y, those can be eliminated. What we're left with is 0 equals 14. So 0 doesn't equal 14, so I know this is no solution. Next one, I have a y, and that's all by itself. So what that tells me is I can use substitution and take x plus 0.6 and plug it in for y. So we have 5x minus 5 times x plus 0.6 equals a negative 3. So 5x minus 5x and negative 5 times 0.6 gives us a negative 3. 5x minus 5x gives us 0. Negative 3 then equals negative 3. That's true. This has infinitely many solutions because they are the same line. Here again I have x by itself, so I can take 8y plus 3 and plug it in for x. So 4y plus 5 times 8y plus 3 equals 15. 4y equals 40y, or not equals 40y, plus 40y, plus 15 equals 15. 4y plus 40y equals 44y. Minus 15, or plus 15, equals 15. If we subtract 15, we get 44y equals 0. Divide 44. I know that y equals 0. Then we can plug that 0 back in for our y. So x equals 8 times 0 plus 3. X equals 0 plus 3, which is 3. Our solution is one solution, and that solution is 3, 0. Alright, this problem says a sporting goods store stocks a better set of golf clubs in both left-handed and right-handed sets. The set of left-handed golf clubs sells for X dollars, and the set of right-handed clubs sells for Y dollars. In 1 month, the store sells 2 sets of left-handed golf clubs and 12 sets of right-handed golf clubs for a total of $1,859.30. The next month, the store sells 2 sets of left-handed golf clubs and 22 sets of right-handed golf clubs for a total of $3,158.80. Is there enough information to determine the cost of each kind of set? So we know that the left hand sells for X dollars. So the first month they sell 2 sets of left-handed. So 2X. Then they add to that sale of 12 sets of right-handed. Right-handed is Y. So 12 times Y equals $1,859.30. The next month, they sell 2 sets of left-handed golf clubs again, so 2 times X plus 22 sets of right-handed clubs, and that is $3,158.80. Now, I see that I have two 2x's, so I can subtract these so I can eliminate them. So 2x minus 2x eliminates. 12y minus 22y is negative 10y. And then $1,059.30 subtracted by $3,158.80. So I'm going to put this into my calculator because my smaller number's on top. We get negative $1,299.50. Then I can divide by a negative 10. So y is going to equal $129.95. So that is the cost of a set of right-handed golf clubs. Now we need to find the cost of a left-handed golf clubs. So we're going to take that number and put it in for y. So we'll have 2x plus 12 times $129.95 equals $1,859.30. So 12 times 129.95, we get 2x plus $1,559.40. Then if we subtract this, those cancel, we get 2x equals 0 minus 0 is 0, 3 minus 4, we gotta take 1 from the next one, that becomes 8, that becomes 13, 13 minus 4 gives us 9, this one we have to take 1 from the next one, that becomes 4, this becomes 18, 18 minus 9 gives us 9, this one we have to take 1 from the next one, that becomes 7, that becomes 14. 14 minus 5 gives us 9. 7 minus 5 gives us 2. And 1 minus 1 gives us 0. Lastly, we divide this by 2. X equals $149.95. So it costs a little bit more to get a left-handed golf club set than it does a right-handed golf club set. There was enough information for us to determine the cost, and we did it. We found x and y. So this is for your notebook. One solution is where the lines intersect. No solution are where they're parallel. And infinitely many solutions are where the lines coincide or they are the same line.